Okay, question 3. I'm going to do this very quickly. This was done particularly well on the mocks, largely because it's a very recent topic. So if you hadn't done any revision, it's more recent in your learning, and because I think you understood it pretty well through teaching. So it says we've got carbon-13 and carbon-14, and they're isotopes. So they're isotopes because the atomic number or the proton number is the same, and the mass number is different. And it says complete the table for carbon-13 and carbon-12. So number of neutrons, well, we know we've got to take those away. So 6 from 13 for the neutrons in carbon-13. That's going to be 7. And then Goodman then. And then 6, number of electrons is the bottom number. It's number of protons, electrons, 6. Okay, next one, carbon-14. 6 away from 14 is 8. And again, the bottom number tells me the number of protons or the number of electrons, 6. And I think it's 1 mark for each row, each column, actually. So mark, mark. Next part, it says name an instrument that can be used to measure radioactivity. That is a Geiger counter. So if Rasand is watching this, don't spell it as a giga counter, because that means something else in science, but it made me chuckle when I saw it in your book. And then the next one, state 2 sources of background radiation. We got loads. So I could do cosmic radiation, rocks. I can go to buildings, food, water. I'm going to go with 2 that I know, and I'm just going to go with, I'll go with the sun, and I'm going to go with rocks, and if I wanted to, I could go with air, so from radioactive atoms in the air like argon. Now, ultimately, most of this stuff in the air actually comes from decay from rocks. Okay, on to the next question. Your half-life questions are done particularly well, so I'll go really quickly over this. Carbon-14 is radioactive and has a half-life of 5,700 years. The number of radioactive carbon atoms has decreased from 1 million to 125. Determine the age. So doing what I taught you, take the initial activity, 1 million, and write the start. Arrow, well, that'll go half it, 500,000. Still not got to where I want to be, 125,000. 1 half-life. Half it again, 250,000. 2, half it again, 125,000. 3 half-lives. 3 times 5,700 is going to equal 17,100 years. And that's done really well now on pretty much every single test. You'll probably do it far better than me because you'll write it loads neater than that. I'll try and tidy my writing up now. And it then says carbon-14 decays into nitrogen-14. So I'm just going to go and have a look at that. So carbon-14 is 614. And then it says it's going to go to nitrogen-14, N714. Well, I can see instantly, if I change my colour, this bottom number's gone up. So it's telling me this is beta decay. So it says what happens in terms of the nucleus that enables it to decay into nitrogen-14. So now I've got to use my knowledge of beta decay. So a neutron. I'm going to quickly check the mark scheme to just say a neutron decays to a proton, mark, and then we know that beta or an electron is emitted. All right, so a beta, which is a fast moving, or actually I don't like that, I'm going to go with which is a high velocity electron is emitted. And you would have learnt it like this. So carbon 614 will decay into 714N plus beta minus 1, 0. My beta's a bit wonky, but that's, there we go. And I hope that makes sense. Now, a really nice thing to do is use the equation if you can. One of the key things from the mock is if you'd used equations within your 6 marker, which you can just look up in your book, loads you've done, loads better. But that's question 3, done.